Panthers. Today we are going to talk about exponential functions. So we have three graphs: y equals 2x, y equals 2x squared, and y equals 2 raised to the x. So looking at the first graph, we know that this is linear because the exponent is a 1, but we also know the number in front of the x is going to be our slope. And so graphing this, we went up 2 over 1, up 2 over 1. And so this 2 right here is our slope. So our slope is 2. We know our y-intercept, which is this point right here, is 0, 0. So y-intercept is 0, 0. Looking over here, this is our parabola. We just got done talking about quadratics. And so y equals 2x squared. The parabola is quadratic. Quadratic has the highest exponent of a power of 2. And so we know that this is a quadratic. This has a vertex of 0, 0. Looking at the third graph, this is y equals 2 raised to the x power. And this graph right here, I did not do a very good job of connecting that, is that this is what we call an increasing. And this is what we call a growth. As I go from left to right, my x is increasing and so is my y. And so this is an increasing exponential function. And I can rewrite this as y is equal to, there is a 1 times 2 to the x. So it looks like that. And we have a formula, and our formula is y is equal to a times b to the x. And so the a is what we call the initial value. And hopefully you can remember that anything that we call initial value is our y-intercept. And then the b is what we call our decay or growth factor, depending on whether it's increasing or decreasing. And so this is going to be a growth. And so this is growth or decay factor. And this little x is going to be time. So in order to find b, we have a formula for b, and b is going to equal 1 plus r, or it can be 1 minus r. Depending on if it's a growth, we would use this formula, and if it's a decay, we would use this formula. And these would be if it's going to be a percent. So we would use that if it's a percent. So this right here is going to be exponential. So as I talked about it earlier, this is going to be an increasing or a growth. And so this line right here is my exponential function y equals 2x is reaching towards this x-axis, but it's never going to actually get there. Is that this y is constantly getting smaller and smaller and smaller, but it will never actually get to the point where it reaches the x-axis. And so we actually have what we call a line, and we call that the horizontal asymptote. And so this little dashed line right here is where it's trying to get to, but it will actually never get there. And so the horizontal asymptote is going to be x is equal to the x-axis. So it's actually the x-axis is our horizontal asymptote, which also is known as y is equal to 0. And that's our horizontal asymptote. And an asymptote is just a line that is reaching towards, but it will never actually get there. And this is horizontal because it's this direction right here, and that's horizontal. And so for our purposes, we will always have a horizontal asymptote in our exponential. So it's this line right here. We're not going to be talking about the vertical asymptote, which will be over here. We are talking about horizontal. So our horizontal asymptote is y equals 0, which is your x-axis. All right. The second part of what we want to talk about for exponential is that we have to determine whether our tables are going to be linear, quadratic, or exponential. In order to be linear, we have to have a constant rate of change, which means we have to have a slope. Quadratic does not have a slope. And so we want to look at the first difference. And so you can either go find the slope between the top, the middle, and the last and see if it's the same, or you can just go look at the first difference. And so we can look at delta y over delta x, which is also known as the slope. And so I want you to go, you can either find the slope of all of these, or you can look at the first difference. So please go do that and then hop back on. All right, if you would have went to find your slope would be 2. I went and looked at my first difference over here, and so I took negative 2 minus a negative 4, and that is 2. 0 minus a negative 2, which is 2. 2 minus 0, which is 2. And then 4 minus 2, which is 2. I also looked to make sure that my delta x's are the same, and so that would be 2 minus 1. So I know my delta x is just going to be 1. So I looked at the first difference. And the first difference is the same, and this is known as slope. We also talked about what to look at for quadratic. Quadratic, you have to look at the second difference, and so take a second, go look at your second difference, and then pop back on. So your second difference is 4, so I took 2 minus 8, came up with negative 6, and so you can see my first difference is negative 6, negative 2, 2, and 6, and then I took negative 2 minus a negative 6, I took 2 minus a negative 2, and 6 minus 2, and my second difference is going to be 4. And so since your second difference is the same, this is going to be quadratic. And so let's go look at this last graph. And so this right here is 0, 1, which is our y-intercept, and that's where that 1 right there comes from. And so this right here, this 2, is what we call our b value, which is our growth. And so let's see how we can go ahead and find that. And so basically what we're going to do is we're going to take our second, which is 0.5, and we're going to divide that by 0.25. And so 0.5 divided by 0.25 is going to give me 2. And that is where our growth factor comes in. So we take the second divided by the first. You can go ahead and do that all the way around. And so 1 divided by 0.5 is equal to 2. 2 divided by 1, which is 2, and 4 divided by 2, which is 2. And so pretty much what we're doing is we're multiplying. So this is going to be exponential because we're multiplying consistently by a number. So multiply consistently by 2, because 2 times 4, 1 times 2, 0.5 times 2, and 0.25 times 2 will give us that number. So that is how that works. So we are multiplying consistently, even though we did divide just to find out what that growth factor or decay will be. In exponential, we have to use the word multiplication. So we are multiplying consistently by 2. So that is how you come up with your growth factor. You'll take the second divided by the first, third divided by second, just like everything we did when we went to find our common difference before. And we've actually used this formula, I don't know if you remember that, but we did when we were finding our geometric sequences. All right, an exponential function is a function whose independent variable is the exponential dependent of the outcome. Okay, so I'll go ahead and write that down again. And so that's going to be whose independent variable is the exponent. So an exponential function is a function whose independent variable is the exponent. All right, so we're going to fill in the tables of the graph for y equals 3 raised to the x. So why don't you get your calculator and see if you can figure out how to do that. And so remember, your exponent is going to be this caret right here. All right, so I like to rewrite that as y is equal to 1 times 3 raised to the x. right here is my y-intercept. This right here tells me that I have a growth, and so this is going to be growing. So I would expect it to be looking like this when I finish. I'm going to have it increasing. My x is increasing, my y will be increasing. And if I was to go in and look at 3 divided by 1, that's 3. 9 divided by 3, that's going to give me 3. And so this right here is going to be a growth in this case. And so we want to go ahead and plot all those points. We go -2, and that's going to be very, very close to the x-axis. -1, it's a little bit bigger. Then we have 0, 1, and then we'll have 1, 3, then we'll have 2, 9. And so we'll just go ahead and graph that. And then we want to make sure that we put our arrows. Okay. And then we're going to graph the horizontal asymptote. And so it's reaching towards the x-axis right here. And so that is y is equal to 0. And that's going to be our horizontal asymptote. That's the horizontal one. Because it's trying to reach there, but it's never going to get there. And so that's y equals 0. That is also going to be our x-axis. I don't know which one they will ask, but we need to put both of those. And so down here would be y is equal to 0, or let's put the x-axis also, because they do like to ask both of those. And then our domain. So our domain, we have no left. And then you ask yourself, do we have a right? And we do not. And so there's no left, no right, and so our domain is going to be all real. And so sometimes the way that they write that, and only on exponentials, is that you'll see it as y is going to be greater than or equal to -infinity, like that. So I've seen it on the star, just like that, -infinity to +infinity. So you might want to get used to seeing it like that. I've seen it as all real, and x is greater than or equal to -infinity and less than or equal to +infinity. Then the range, so you ask yourself, so is it ever going to equal that the x-axis? Well, it's not, so it has to be greater than. So y is greater than 0. You cannot have an equal sign because it's never going to equal that point. All right, so it says use your graph. Use your calculator to go graph y equals 4x, y equals 10 to the x, y equals parentheses 1/2 x, and y equals 1/5 x. What do all the graphs have in common? And what differences do the graphs, and what's causing these differences? So let's go see what you can come up with for all of these. And then we'll come back in and I'll show you what I came up with. All right, so what I found is that all of them go through 0, 1, which is their y-intercept. They all have a horizontal asymptote, and they all increase on one end and decrease on the other. Some are growths, some are decays. If b is greater than 1, it's a growth and they increase. If b is greater than 0 and less than 1, then they are going to be a decrease. So those are some of the things that I found. All right, so the next we want to identify each function as linear, quadratic, or exponential. And so we have a table, and so we know if it's a linear, we're going to look at the first difference. If it's quadratic, we're going to look at the second difference. If it's exponential, we are going to see if it's going to be multiplying by the same number. So let's see what you can come up with. And so I always go in, and we know that if -1 and 1, if it's quadratic, you would expect to see this to be a -2 and this to be a -2. So more than likely, this is not going to be quadratic. These are all off by, the intervals are by 1. So we can go in and look at the first difference. So 4 minus 7 is going to be a -3. 1 minus 4 is a -3. A negative 2 minus a 1 is a negative 3. A negative 5 minus a negative 2 is a negative 3. So this right here tells me the first difference is the same. So this is going to be linear, and I spelled that wrong. That's going to be linear because this is the first difference. This right here is exponential, and so this could be written as 1 times 1/4 to the x. And so this is going to be exponential. This is our initial value. And this right here tells me that since this is going to be less than 1 and greater than 0, then I know that this is going to be a decay. On number 3, well, we already know that this is a parabola, so that's going to be quadratic. Looking at this looks like this is increasing, and so this is going to be exponential. We also know that this right here is the value of our y-intercept, which is going to be our a, so our a is equal to 2. We can tell that this line right here is our horizontal asymptote. And so we can tell that it's reaching for that line right there. That's our horizontal asymptote. We can tell also that our domain and range, and our domain is going to be all real, and x is greater than or equal to infinity, negative infinity, and you can see it like that. And sometimes they write it with the equal sign, sometimes they don't. It doesn't really matter. It depends on, if it's a multiple choice, just pick the one that has that. And then our range is y is going to be, so these are, let's see, this goes 4, 2, so these looks like these are going down by 2, so our range is going to be y is greater than 0. Our asymptote is going to be y is equal to 0. So we can get all of that from our exponential. So you go ahead and do problem number 5 and 6. Example number 5 is quadratic. The second difference is 2. Number 6 is linear because it has an exponent of a 1 that tells me this is going to be linear. This is the form y equals mx plus b. All right, on number 7, the population of Smallville was 234,710 in 2000. If the population is growing at a rate of 9% per year and can be modeled by the function f of x equals 234,710 times 1.09. So remember that this is going to be b. It's going to be 1 plus r, because earlier I had told you back over here on this page right here that b equals 1 plus or 1 minus, and that this is a growth. So 1 plus r or 1 minus r. And so where x represents 2,000, find the population. And so this actually is 234,710 times 1 plus 0.09. And then x is your time, and that's in years, so that's going to be raised to the 10. And so this is a growth. And so sometimes they ask you, what is your rate? How much is it growing at? And of course, this is growing at over 100. And then you pick up your calculator. And then we would just go to the calculator and we will type in 234,710 parentheses 1 plus or 1.09, doesn't really matter how you do it. Oops, I got that at 1.09. Exponent raised to the 10. And that's going to be y is equal to 555,644 people. And that's how you would do that problem right there. So go see if you can do that last problem. At 0.2 because it's 20 cents. And then you have a label of